Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to go over the second part of the Geometry Regents Exam of January 2026. We have, as you see, 7 questions, and each one is worth 2 credits. In the first one, it says you have a triangle that has vertices with coordinates 2 and 1, 0, 3, -2 and -1. Determine and state the coordinates of the vertices of the image of the triangle after a reflection over the x, followed by a translation of 3 units right and 2 units down. The use of the set of axes below is optional. We really don't need it. We know that if we call these ABC, we know that if you are going to reflect over the x, then all what we do is to change the sign of the y. So the y, you will multiply, it's as if you are multiplying that coordinate by -1. So after our x, now our a prime would be 2, -1, our b prime would be 0, -3, and our c prime would be -2, +1. Okay, so that's the first operation. The second operation is a translation, 3 units to the right and 2 units down, so -2. So I'm going to add 3 to the x and subtract 2 from the y. So our a double prime, if that's the final image, if we assume that this is the first image and that is the second, since we are doing 2 operations, I'm going to add 3 here, so it becomes 5. Subtract 2 from -1. So subtract 2 from -1, it's -3. B double prime would be 3, -5, and C double prime would be 1 and -1. Right? And that's it. You don't need to plot it. You could, but it's going to take time. And since they say the use is optional, there is no reason really to waste your time. So that's the first question. When we move to the second one, it says a cylindrical bucket is being used to transport topsoil. So I have a bucket. The bucket has an inside diameter of 10 and a height of 15. So basically the bucket looks something like that. So, of course, it's not to scale at all. This is 15. This diameter, well, the inside is 10 inch. And we don't care about the outside because we are going to place topsoil. So really, what we need to do is to find this volume, right? The inside volume. And then the weight is 0.0231 pound per cubic inch. So first you find the volume. So we can say the weight of the topsoil equals volume times weight per unit volume. So what is the volume of a cylinder? The volume of the cylinder is the pi r square, which is the area of the base times the height. Now, if the inside diameter is 10 inches, then r would be 5 inches. So here we can say pi 5 square times 15, that would give me the volume. And then I multiply it by the weight per unit volume. And I need it to the nearest pound. So I'm going to say pi times 25 times 15, in fact, 375 times 0.0231. And that gives me 27 pounds. And basically, that's the nearest pound. So again, pi r square would give me the area of the base. And since that area doesn't change, so all what you have to do is to multiply it by the height. And you know the volume of the cylinder anyway, it's pi r square h. And then that's the volume. And each cubic inch, these are in cubic inches. And each cubic inch weighs 0.0231 pounds. So you multiply it by 0.0231, and you get that in pounds. Okay, that's the second one. The third one says, in right triangle SRT, the measure of angle R is 90 degrees. So this is angle R, and this is 90 degrees. The measure of S, so if we assume this is S, is 27 degrees. And ST is 31.8. They want the measure of segment SR. See, that's the hypotenuse, that's the adjacent. So all what come to your mind is adjacent over hypotenuse. So SR divided by 31.8 equals the cosine of the angle 27, because the cosine is adjacent over hypotenuse. Adjacent over hypotenuse is cosine 27 degrees. So I'm going to multiply both sides by 31.8. Use the calculator. I think it's still, I never changed the mode, but just, yeah, it's in degrees. So I'm going to say 31.8 cos 27, and the nearest tenth, and that should be 28.3. They didn't give us units, so you can say unit, but they didn't say centimeters or inch or anything. So just the number is good enough. Okay, next problem. Triangle let has LE is 7.5, ET is 9.3, and the measure of angle LET is 115. Determine and state the area of this triangle. You should know that the triangle, the area of the triangle is 1/2. Well, basically the original is that the area equals 1/2 both sides. So ET, for example, ET times EL times the sine of the angle between them. Now, if it's a right triangle, sine 90 is 1, and you get 1/2 base times height. Some people can construct the height and try to find the length using, you don't need to do that. You can always say the area equals 1/2 times 7.5 times 9.3 times sine of 150. That's all. Okay. Notice that if I had constructed the height, so the base is, so it's 1/2 base times the height. But what is the height? You see that if this angle is 115, that this angle is the supplementary, or 180 minus that, which is 65 degrees. And this height would be 7.5 sine 65 degrees. Correct? So the area would be 1/2 times 9.3 times 7.5 sine, oh, it's sine 65, not sine 115. But you know that the sine of supplementary angles is the same because the sine is positive in the first two quadrants. So whether I say 30 or 150, it's the same thing. And you can see that it's a lot of work. Eventually, we'll get the same result. Okay, so you need to memorize that. The area of a triangle is 1/2 two adjacent bases times the sine of the angle between them. So I get 0.5 times 7.5 times 9.3 sine 65 or 115, it doesn't matter. It's the same thing. And to the nearest tenth, you get 31.6 square units. Yeah, it's better even in the previous one to say unit, because they didn't tell you like what units they use, but it's better to say square unit than to leave it just a number that doesn't make sense. So it's better. Even the previous problem, when we found the which one? Yeah, the length. That's what I wanted to say. It's better to say unit, whatever unit you are using. I don't think that will take points if you don't, because they didn't specify a unit. But anyway, a pool owner has a circular deck that surrounds her circular pool, as modeled in the diagram. Excuse me. The pool has a diameter of 24 feet. The distance from the edge of the pool to the outer edge of the deck is 8 feet. Determine and state the number of square feet of the deck to the nearest square foot. Yeah, of course, we see that you have to subtract the area of the pool from the outside, from the outer area, right? So our pool is 12 feet and our outer is 12 plus 8, right? It's 12. This is 12 plus 8 is 20 feet. So you would say the area of the deck equals pi r square, which is 20 square, minus pi r inner square. So you can factor the pi out and you get 20 square minus 12 square equals pi times 400 minus 144 equals 256 pi square feet. Of course, you use the calculator and get that to the nearest square foot. So pi times 256, you get 804 feet square. So you see they are really pretty straightforward. If you know your geometry or areas and volumes of common shapes, you should be fine. Use a compass and a straight edge to construct an equilateral triangle with AB, that segment shown below, as one of the sides. Yeah, that should be an easy one. We know the equilateral triangle has all the sides equal. So you need to measure that. So we are going to use the compass. Oops. To open that until I go to A, I would need a sharper, that would be better. I think this is good enough. So we are going to take an arc like that and then go to A and draw another arc. Oops. Oops, you need a younger person than me. Okay, much younger, like 3 times younger or 4 times like you. Okay, so now we know that now since these two arcs are congruent, then definitely that would produce, where is, this one is, I'm gonna use just the straight edge. So here is the vertex of my equilateral triangle. And I told you to leave the marks so they know how you constructed it. Don't erase them. And basically this is the equilateral triangle. You can call the vertex C or something, makes sense since it's AB. Or it doesn't matter since they didn't ask you, they simply said, construct an equilateral triangle. That was an easy one. Okay, so I think 2 more. No, that's it. Did we do 7? No, that's number 30. So where is 31? Need to print out. Oh my God. I don't see number 31. How is that possible? 29. Sorry guys, I don't know how does that happen? I was printing and the printer will never skip a page. I mean, that doesn't make any sense. And it's not falling somewhere. So, or, oh, maybe, oh, it's in the back here. Oh my God. Okay. Sorry, guys. Oh my God. In the diagram below, right triangle ABC is inscribed in the circle with right angle ABC. Okay. Explain why AC must be the diameter of the circle. Well, we know that if this angle is 90 degrees, then this angle is 180 degrees. The measure of this arc is 180 degrees, and that basically means AC is a diameter, right? So we can say the measure of arc AC equals 180 degrees, since angle ABC is 90 degrees. That's definitely the double. Hence, it is the diameter. I don't know how they want us to explain it, but I think that should be enough. Maybe we'll try to check that. But basically, that's the end of part 2. It's 20 minutes. Maybe I will do parts 3 and 4 later and post them. But I think I'll stop here. So I don't want all the videos to be lengthy. And again, if you have any questions or comments, please let me know. Otherwise, I'll see you tomorrow, and best of luck. Bye.